This is Algebra 1, Term 3, Lesson number 12, Mixed Models. Today we'll be looking at a free ticket to Disney World. We'll be discussing graphs of exponentials and linear functions. We'll also be doing a question stack and practicing doing a little bit of average rate of change calculations. Let's take a look at our free ticket activity. First, you're going to watch a video. This video has been floating around for quite a while this year. It was actually on Twitter where I saw it first, but there's a whole website about this. I've left you a link to a news article in your teacher guide. So let's take a look at this video.
I tried getting into Disney World with a 46-year-old ticket originally worth $8. It's been collecting dust since before I was born, and I always assumed that it was just an old family keepsake, till I realized that it's never been used, and there's no expiration date. Which means I've either found the golden ticket here, or I'm delusional thinking that the mouse is gonna let me use it to get inside nearly half a century later. So naturally, I flew to Orlando to find out. Hi, I have a ticket for a day at the Magic Kingdom, but it's from 1978.
So this was for Magic Kingdom?
A few moments later.
I was getting nervous there because she started aggressively stamping void all over the ticket booklet and then left. But she did come back with this yellow pass, which supposedly is good to get into the park. I can't believe this actually worked. Now today, that same ticket would cost more than 20 times its original value.
So the first question is, how much did the value increase, and should this be modeled with a linear or nonlinear function? We are just asking for students' opinions at this point. They may have a good idea of which makes the most sense, but right now either one is fine. Have them explain their thinking. Once they've done that, we're going to move on and analyze this using a linear model. So for the linear model, they are asked to create a table, a graph, and an equation. We're going to use 0 for our input for the year 1978, so the age of the ticket would be 0 in that year, and use that model to determine the value in the year 2000. So once they've created their equation, they can use Desmos, of course, to create a table, graph, and an equation. Then they will need to use that model to predict the value in the year 2000. Once we've done that with our linear model, we're going to turn around and do this again. Next, we're going to create an exponential model. For the same data, we still have just 2 points, 0, 8, and 46, 164. Let's put that in a table and use the regression equation y1 tilde a times b to the x1 power, and that will give them a graph. It will give them an equation, and they already have their table if they put those in their Desmos calculator, and they'll just take a screen capture of all that, or they can export the graph and screen capture the rest. Now once they've done that, they want to use the model to determine the value of the ticket in the year 2000. So just like we always do, we'll use the equation that it gave us, and we'll replace the input value with the x value that corresponds to the year 2000. I'm not going to tell them that value. I do expect them to figure out the value of x that would correspond with the year 2000. And just like before, we're going to compare that output that we get using our model with what people are saying online. If you go Google, I found one in Reddit that was pretty good, and I think that one's probably my favorite guess, but I did find another, actually 3 different values for the price of the ticket in 2000. So they just need to pick one that they like best and compare to that value. Once they've done that, we're going to put them together. So on this next screen, we're actually going to have a table with 3 order pairs. We're going to take the first 2 order pairs that were given on the last screen, and we're going to add a 3rd order pair for the year 2000. And again, we're going to generate a linear equation using y1 tilde mx1 plus b, and we're going to generate an exponential equation, y1 tilde a times b to the x1 power. Both of them will graph over the data, the 3 data points, and then they can visually see whether one fits better than the other. And they can also examine their residuals. Now, depending on how they did it, if they created two different tables, they could do one of the tables for linear and then create an identical table and do one for exponential, and then they'll have two sets of residuals. However you want to do it. They don't technically have to graph the residuals. I did not specify what I wanted on the screenshots or the graph, so you could just tell them the residuals are just for you to look at. You don't have to graph them. You don't have to leave them on there when you graph them, but basically the residuals are showing the error. And since you only have 3 data points, you've only got 3 residuals to look at for each one of these. So which one produced smaller residuals? Those are points closer to 0. So which one does fit better? So let them make that decision. I will be giving you examples of all of this in your teacher guide, in your show notes, and I will show you the graphs that you get with this data and the numbers that are out there, at least the ones I've found for the ticket price in the year 2000. The next thing we're going to do is a Desmos activity. And this activity is very short. It's really just a polygraph. So we're going to do polygraph exponentials. There's a lot of text here you can read, but our goal here is to build their vocabulary. So we want to reward kids for choosing rich mathematical vocabulary as they do this activity. There's some key vocabulary that they've listed here: increasing, decreasing, intercepts, rate, asymptote, curved, exponential growth, exponential decay, and so forth, linear. And so here's all it is. It's just one screen, and it is a polygraph. I would suggest at least 2 rounds, probably 3 is a good minimum for this one. So the students will see these graphs that you're seeing on my screen now, on your screen now, and then they will have to basically choose a graph, and then the other students ask yes/no questions to try to narrow down the graphs to the one right answer. And of course they win the round if they choose the correct graph or the one that your student has chosen. So they've got lots of things they can talk about, whether the graph is increasing, decreasing, curved, straight, linear, nonlinear, and so forth. So again, celebrate all the rich vocabulary that you hear. I like to write words on the board as I hear them. I even pass out little prizes like a free toy or a mint or something. So just anything I can do to encourage them to use the right vocabulary. You don't say that thingy or this over, this is going to the right. I want to know, what do you mean? Yeah. So anything they can use mathematical in these explanations, celebrate that. Okay, our last activity, something way different, and that is a question stack. They will work with a teammate. This is really a good partner activity. You could have whole teams work together, but I think, and Sarah, the one who wrote this initially, suggests teams of 2, and I agree. I think that would work best. So if you have teams of 4, that works kind of nicely, and that's usually what I have was teams of 4. So I would just pair them up that way. All right, so on the question stack, they will have a stack of 10 cards. On one side of the card is a question. On the back of the card is an answer. The answer does not match the question. They have to find the questions. And so I'm going to take you to her site to show you. I've given you a link to this in the teacher guide and also in your show notes for this activity. This is average rate of change self-checking activity. Now the actual activity she made was for pre-calculus, so I just took her activity. Same activity. I left some of the cards exactly the same, but I did change quite a few because I didn't want to have cubic functions and other things that we don't really study in algebra, and I just changed those to absolute value, exponential, and just made them more suitable for our Algebra 1 kids. But here's what the cards look like, and these are the answers. The students will lay all their cards face down, or answer side up, and they will choose one card to turn over and place on their question stack directions. So they're going to place a card in this space with the question facing up. They will read the question and they will answer the question. And once they do that, they'll look in their little answers, because the one on the back of that question is not the answer. It's one of the others. So they're going to look at all these answers and see, is there my answer out here? If they don't see their answer, then they know there must be a mistake, and then they will continue working on it. So here's some of the questions she had. I took that one out. That was a sine function. And I took this one out because we don't do rational functions either. Anyway, she suggests that you cut these out and laminate them. She also says you could use business cards because they're perforated and they're easy to use, but you can't really laminate those, I don't guess. But once they've chosen an answer, they're going to place the answer on top of the question. Like they'll take the answer, turn it over so that the answer's facing the question that it's answering. And then the new question is going to be on the back of that question. So that'll be the one they do next. And then again, they'll look for their answer. This is self-checking because all the answers are there. There's one, there's only one answer per question. None of them are duplicates. So they should all have the same result. Now, having said that, I didn't really tell them how to show their work or to do their work. If you'll notice here, they're working on mini whiteboards, so they wouldn't really have a record of that unless they took a picture of it. You could have them take pictures of work on a whiteboard and put it on their slides. You could also just have them write on a piece of notebook paper and turn in the piece of notebook paper, and that's perfectly fine. So however you want to do it, I did instruct the students to ask their teacher how to document their work. So however you would like to have that done is fine. You might even make up a little blank sheet with 10 spots on it for them to just write the work in the little spots on the sheet for each question. Okay, so a nice little different, not digital activity. So I know they've been on Chromebooks every day. We started out with a couple of paper activities at the very beginning of the first term, and I've had almost none since. So I thought, it's about time. Now this is skill practice. I'm not a huge fan of skill practice, but it is a variety of problems. They're not all exactly the same questions. Some are graphs, some are tables, some are equations. So I did try to mix it up, and it is of course a little different. So since it's different, hopefully they will tolerate it just a little better. And that concludes our mixed models lesson. Y'all have a great day.